All right, let's get these last four examples done and underway. So I have an expression, 27z cubed to the negative 2/3. I'm going to go ahead and distribute that exponent, and I know I can because there's no addition or subtraction. So let's see, I'll get 27 to the negative 2/3. And then when you have an exponential expression to an exponent, it's a power to a power, you can go ahead and multiply your 3 and your negative 2/3. If you're not confident with them, you can always do 3 times negative 2 divided by 3 in your calculator. You'll get z to the negative 2. Now those are both currently living on the wrong side of the fraction, so I'm going to move them both down to the denominator. When you move them down to the denominator, they have to be under something, and remember the secret number that's always there is a 1 in the numerator, so even if you get rid of everything that was up there, the 1 would still be there. So then I have 27 to the positive 2/3 z squared. And then I can rewrite my fractional exponent as a radical. So really this is going to be 1 over the cube root of 27 squared, z squared. And I think I can reduce that or actually simplify that. No, I'm going to put my final answer up here. Or maybe I can fit it right here. So if I do cube root, which in your graphing calculator, you're going to hit math, and then it will be the fourth selection down. If you wanted to do a bigger root than a cube root, then it would be the fifth selection. So you'll see there's a nice cube root symbol in your math menu. And then right below that, there's an X root symbol. And so if you want to do like the 9th root of something or the 20th root of something, you could use that piece as well. All right, so if I did the cube root of 27 squared, I end up with 9. So it's 1 over 9z squared is my final answer. All right, let's go ahead and do this one. I have no addition or subtraction, so I feel confident distributing that negative 1/3 to each of these pieces. Negative 8 in parentheses, watch that negative. And then times x to the, when you have an exponential expression to another exponent, a power to a power, we do 6 times negative 1/3. So 6 times negative 1/3, you can do it in your calculator, you get negative 2. And then y to the negative 18 times negative 1/3, right, would be a positive 6. Awesome. I see a couple of things that belong on the other side of the fraction, so those are going to go down into my denominator. My y to the 6 will stay up there. So I'll have y to the 6 over, let's see, negative 8 now to the positive, oops, give myself a little more room, negative 8 to the positive 1/3. And then x to the positive 2 now. And so I have y to the 6. And then really, when I'm doing negative 8 to the positive 1/3, that means I'm doing negative 8 to the first. And I'm taking the cube root of that, x squared. And I can go ahead and actually calculate the cube root of negative 8 in my calculator. So math, and then if I go down to my fourth option, that's my cube root of negative 8. Would give me a negative 2. So y to the 6, y to the 6, there we go, over negative 2 x squared. Voila. All right, let's go ahead and tackle these last two bad boys. So in this one, I have just division going on, so I can go ahead and distribute that exponent. And there's nothing to distribute on this piece, this just means multiplying. So I'll get, when you have an exponential expression to an exponent, a power to a power, go ahead and multiply. So a to the 3/2 to the 4th would mean 3/2 times 4, which would be 6. You can double check that in your calculator by doing 3 divided by 2 times 4. And then in the denominator, b to the negative 1/2 to the 4th, negative 1/2 times 4 would give me, a negative 2. And then that's still just multiplying my a to the negative 2, b to the 3rd over here. All right, so now when we're multiplying, you can go straight across top and bottom. Now you can kind of just treat this all as one fraction. I see some things that belong on the other side of your fraction, so I'm going to go ahead and move them to where they belong. So on top, I'll have a to the 6b squared. Those exponents are really, a to the 6. Uh-oh, it's panicking. It's okay, we fixed it. All right, so we get a to the 6, and then these two b's had to go move up, so b squared. All over, I had 3 b's down there, and then, Oh, come on. There we go. And then those two A's move down there as well. So then where do I have more A's, top or bottom? I have on top. How many more? 4 of them. So I have A to the 4th. And then where do I have more B's, top or bottom? On the bottom. How many more? 1. So you're just left with 1 B on the bottom. All right, last one. So let's go ahead and distribute this negative 1/3 because I only have multiplication and division happening here. So negative 1/3 goes to every piece. When you have an exponential expression to an exponent, a power to a power, you go ahead and multiply. So we get x to the 6 times negative 1/3 is negative 2. And then negative 3 times negative 1/3 would be a positive 1. On the bottom, my 27 just goes ahead and gets that negative 1/3 as its exponent. And then y to the 3/5 to the negative 1/3 would be multiply those together. So you'd end up with y to the negative 1/5. And again, check all those fraction multiplications in your calculator if you don't feel comfortable with them, okay? So then I see a lot of things that have to go to the other side of the fraction where they belong. Oh, this has to come down too. My goodness, just can't make up their mind. All right, so then this simplifies too. On top, I have 27 now to the positive 1/3. This y to the first stayed up there, so just a y. And then a y now to the positive 1/5. And then on the bottom, the only thing I'll have down there is an x squared. All right, so now on top, you can rewrite 27 to the 1/3 using a radical because you got power over index. So it'd be 27, and then you're just taking the cube or root of it. Y to the first times y to the 1/5. When you're just multiplying bases, you add the exponents. So again, if you want to do in your calculator 1 plus 1 divided by 5, that's how you do 1 plus 1/5. It gives you a fraction. Go ahead, or excuse me, a decimal. Go ahead, hit math, enter, enter to get to your fraction. So y to the 6/5, and then in the denominator, still have the x squared. All right, last step. You can actually take the cube root of 27, you get the number 3. We can rewrite our y to the 6/5 in radical form, so y to the 6, but it's underneath the 5th root. And then you still have an x squared in the denominator, and that's your final answer. Whew, good job making it through all these examples, you guys. The more examples you do, the more familiar you become with it, the more shortcuts you learn, and it's better all around, okay? So let me know if you have any questions, but other than that, you're just practicing simplifying exponential expressions this week. So all the examples we did, those will probably be the hardest ones you see. Let me know if you have any questions.